Okay, right. In this lecture, we'll cover graphs of inverse trigonometric functions. We have already covered trigonometric functions and their graphs. So now I don't think it's difficult for you to understand why these graphs are the way I have drawn them. First thing, f of x equals sine inverse x. Domain of sine inverse, likewise cos inverse x, is -1 to 1. Why? We'll come to that point later on. But domain of these two functions is -1 to 1. Sine inverse x, range of this function is from -π/2 to π/2. Range of cos inverse x is from 0 to pi. Okay, now this is not a very difficult graph to understand. So let's draw sine x from -π/2 to π/2 and cos x from 0 to pi. Why these two functions I have drawn for different domains, -π/2 to π/2 and 0 to pi? This has there is a concept we call inverse of the function. You need to understand, but again I'll explain. We choose a domain of this sine x in such a way that this function is 1 to 1 and on to. So sine x from -π/2 to cos x from 0 to pi. So observe this function. This function passes through origin. Likewise, this will pass through origin because these two functions are inverse of each other. This pi/2 y coordinate is 1. Likewise, at 1 we'll be getting pi/2. So these x coordinate is angle and this output real number -1 to 1. Likewise, -1 to 1 and these y coordinate is angle. So at pi/2 y coordinate is +1. Likewise, +1 will give you pi/2. -π/2 gives -1. Likewise, -1 will give you -π/2. Because these two functions are inverse of each other, they are reflection of each other about y equals x. You can do that yourself. Likewise, cos x, at 0 y coordinate is +1. So at x equals 1 y coordinate is 0. At pi/2 y coordinate is 0. So at 0 you are getting y coordinate pi/2. At pi y coordinate is -1. So at -1 y coordinate is pi. Slight difference, sine inverse x and cos inverse x, domain is -1 to 1, but range sine inverse x -π/2 to pi/2 and this is 0 to pi. Means third quadrant and fourth quadrant, sorry, first and fourth quadrant, and this gives first and second quadrant. Okay, tan inverse x and cot inverse x, I'll explain tan inverse x, then leave cot x for you, then cosec inverse x, and then leave sec x for you. Okay, so tan inverse x, this is graph of tan inverse x. Domain is -∞ to +∞. Range is -π/2 to pi/2. But unlike sine inverse x, these two extreme points are excluded. So -π/2 to pi/2 except endpoints. Cot inverse x, domain is -∞ to +∞, means real number, and range is 0 to pi except endpoints like 0 to pi. But at this cot inverse x will not give you 0 and pi. Okay, let's talk about tan inverse. Why tan inverse x is this? This I have drawn tan x from -π/2 to pi/2, keeping it 1 to 1 and on to. Okay, so this curve passes through origin. Likewise, this will pass through origin. Now observe, when you are moving towards pi/2, your y coordinate is moving towards a very large value. We call it +∞. So when you move towards pi/2, but slightly less than pi/2. Okay, so when you move towards pi/2, means from left hand side your y coordinate is moving towards infinite, a very large value. Okay, so let's see, when you are moving to a very large x coordinate, your y coordinate is moving to approach this particular line, but slightly less than pi/2. Okay, so range is pi/2 excluded. Now this, when you move towards -π/2 from right hand side, your y coordinate is moving towards a very large value with a negative sign. Okay, so what is happening here? When you are moving in this direction, your y coordinate is moving towards -π/2, but slightly more than -π/2. Okay, so range is -π/2 to pi/2. Cot inverse x, a domain -∞ to +∞, range 0 to pi. Okay, I'll explain cos inverse x and then leave sec x and sec inverse x to you. Cosec inverse x, domain is 1 to infinite and minus infinity to minus 1, except minus 1 to 1. This is again domain 1 to plus infinite and minus infinity to minus 1. This range is minus pi by 2 to pi by 2, except 0. Except 0. Why 0? Because at x equals 0, cosec x will not be defined, because sin x is 0 at x equals 0, so cosec x will not be defined. So we are not getting y coordinate here, like y equals 0 is excluded. Likewise, sec inverse x range is 0 to pi except midpoint. Why midpoint is excluded? Because at pi by 2 cos x is 0, so sec x will not be defined. Slip of tongue, I'm not very good at it. Okay, so one thing is to observe here is a domain of these two functions minus 1 to 1, domain of these two functions real number, domain of these two functions 1 to infinite and minus infinity to minus 1. Range of these three functions, sine inverse, tan inverse, cosec inverse, more or less same. So sine inverse x minus pi by 2 to pi by 2, tan inverse x exclude endpoints, means minus pi by 2 and pi by 2. This excludes 0, midpoint. This is for the purpose of objectives, very quick objectives, nothing impressive about it. Sec inverse 0 to pi exclude endpoints, 0 to pi except 0 and pi exclude midpoint. Okay, and this is, so why this minus pi by 2 to pi by 2 and these three minus pi by 2 to pi by 2, and why? Because for their trigonometric counterparts we have covered sin x, tan x and cosec x from minus pi by 2 to pi by 2, cos x, cot x, sec x from 0 to pi. Okay, two very good questions on them. We need to solve this equation sin inverse x greater than cos inverse x. Okay, so because we are doing graphical method, so I'll solve it using graphs only. Okay, so draw sin inverse x, which means yellow color. Okay, minus 1 to 1, minus 0 to pi. Okay, this is pi. This is pi by 2. And this orange, I suppose pink is cos inverse x, minus 1 to 1 and range 0 to pi. At their point of intersection, their y coordinates are equal, which means sin inverse x equals cos inverse x. Graph is symmetrical, increasing from minus 1 to 1, means minus pi by 2 to pi by 2. This cos inverse x is decreasing symmetrically from pi to 0. The only reasonable solution is midpoint, means 0 to pi by 2, midpoint pi by 4, which gives us x equals 1 by root 2, which means this point is 1 by root 2. We are interested sin inverse x is greater than cos inverse x, means graph of sin inverse x, which is this is the graph we are talking about. So solution is 1 by root 2 to 1 is included. Okay, suppose I want to draw maximum of it. So maximum, this is maximum. So from minus 1 to 1 by root 2 cos inverse x is greater, 1 by root 2 to 1 sin inverse x is greater, and whatever is left out is minimum of it. So you can try to draw maximum. Okay, I have already drawn maximum, and then minimum is whatever is left out, then tan inverse and cot inverse. You need to calculate minimum of it. Okay, what is something else? But one more thing. Trigonometrical graph and their inverse are symmetrical about y equals x line. Please try to observe, this is concave, this is convex. So convexity and concavity could be an interesting thing to observe. Okay, and we'll talk about rest of the things in my next